Hello. Today you're going to work on a problem that I made up using real data from the coronavirus. So hopefully you've been able to print this out. Otherwise, you could do this on a separate sheet of paper. So Washington State was one of the first states to be hit with the coronavirus. They are also one of the first states to be on the downward slope of the curve that people talk about, which means they have less new positive cases of coronavirus tested each day. Here is data collected from Google. On April 3rd, there were 527 new cases. April 10th, 448 new cases. On the 17th, 330, and the 22nd, 241. So let's make X the days after March 31st and Y the number of new cases of coronavirus. Write the table below. So we can't put dates into Desmos, but we'll make them into numbers. So we're just going to make it the days after March 31st. In your project, it's going to be hours after you wake up. So here's the table that you're going to put into Desmos, and I will do that in just a second. So then from these X values, you'll be able to figure out an actual date. So actually, one of the goals is going to be to estimate when Washington will have 0 new cases of coronavirus. So let's go to Desmos. Now let's make the table. So remember, you press the plus sign, table, 3, 10, 17, 22. And then down the Y's, 527, 448, 330, and 241. Now you'll notice nothing was graphed on the right side here. Do you know why? Well, look at the scales. It doesn't even, they won't show up with this scale. So we're going to press the wrench tool. And then we're going to go, let's fix the x-axis. I'll go from -5 to, well, the highest x we have is 22. Let's go a little bit past there. And we can always change the scale in just a minute. And let's put a label on the x-axis. So what does x represent? Days after March 31. And then the y-axis will be new cases of COVID. Autocorrect. Darn it. COVID in Washington. Okay. And now that, let's see, our numbers go up to 527. We'll go a little higher, so let's start a little lower. And then we'll go all the way up to like 6 something. There. So you can change the zoom with your fingers just to see where you're at. So there you could see, the more days after March 31st, the less new cases detected in Washington. So that makes sense. Okay, so now our goal is to figure out the equation of the line that passes through those points, more or less, to model this change in coronavirus. So let's go back to our notes. So pick 2 points from the table and calculate the equation of the line that connects those points. We are assuming the data is following a linear model. All right, so we have to say that because we know actually when we're modeling viruses, if you've seen the news, they're usually curves. But for this project, we're going to assume that it will stay linear. And so I will pick these 2 points, the early point and the later point. Okay. Next year, in math, you will learn a way to get the official best line of fit, but we're just going to do a line of good fit here. So slope, so you need slope and you need the y-intercept. So slope, or m, equals the change in the y2 minus y1 over x2 minus x1. And that will give us negative 286 over 19, which you could leave. We're also going to write it with the unit rate. So divide negative 286 divided by 19, and you get negative 15.05 over 1. And we'll interpret that in just in the next question. So there's the slope. We'll use the unit rate version. And now we need the y-intercept. So you use y equals mx plus b. And then the negative 15.05 is the m. So there's a partial equation. Now you pick either of those ordered pairs to plug in for x and y. I will pick the first point. So the 527 is the y, and the 3 is the x. So then simplify. Then get b by itself. So you're going to add the 45.15 to both sides. And that is going to give you 572.15 equals b. So the equation is y equals negative 15.05x plus 572.15. Very good. So now let's interpret what the heck are the meanings behind these numbers in the equation. So the slope, we just said, is negative 15.05 over 1. So now, remember, slope is change in y over change in x. Or, using the labels, change in new cases over the change in days. So it's new cases per day, and it's decreasing by 15.05, or about 15. So we're going to say, in Washington State, there are about 15 less cases of COVID each day. All right, so it's always some kind of a rate. So it's the change in the y unit over the change in the x unit, new cases per day. Now the y-intercept, remember, is the b, so it was 572. So we say 0, 572, because it's the y-coordinate where it crosses the y-axis. So now the 0 is the x unit, and the 572 is the y. So 0 days after March 31st, which means on March 31st, there were 572 new cases of COVID. In Washington. Okay. Now I want to go back to the slope for a second. Remember, we calculated the slope as two different numbers. We have the negative 15.05 and the negative 286.19. So it turns out you could keep it in the fraction form if you like, and then it would mean every 19 days there are 286 less cases of coronavirus. But I kind of like the unit rate version. Every day there's 15 less cases. So they're equivalent, but you can just use the unit rate case. Okay, so now from the equation, let's calculate the x-intercept. So these are similar questions to what you're going to have on your project. You'll just type up all your answers in your project in sentences and type all the math. So we use the equation. y equals negative 15.05x plus 572.15. Okay, so then we get, so now the x-intercept, remember, is when the y equals 0. The y-intercept is when x equals 0. So we have 0 equals negative 15.05x plus 572.15. Now we get x by itself. So solve the equation by subtracting 572.15 to both sides. So negative 572.15 equals negative 15.05x. Divide both sides by negative 15.05. And this is going to be 38. So what the heck does that mean? This is an interesting one. So it's 38 comma 0 is the x-intercept. Okay. So what does that mean? So x, remember, is days after March 31st. So 38 days after March 31st, there will be 0 cases of COVID. Okay? Now, that means you can calculate the day. So that would be like April 38th, which we know doesn't exist. There's April 30th, and then 8 days after that will be May 8th. There will be no new cases of COVID. Oh, I should have put the word new up here. So new cases of COVID. Okay? And this is something that, might be useful to some people after high school. Okay, so number 5, from the equation, calculate how many new cases of COVID are expected in Washington on April 28th. Okay, so write the equation. So you're using this equation to make predictions. Again, that's not exactly what would happen, but it is an estimate. So now, so is April 28th going to be the x or the y coordinate? Oh, x. So x will be 28 days after March 31st. And then type this right into the calculator, and you get about 150.75, which you can round to 151 if you like. So that means there will be 151 new cases of corona in Washington on April 28th, which is today if you're doing this assignment when it's due. And you can actually go on tomorrow and look to see if this was accurate, if this was an accurate prediction. Maybe not. Now, using the equation, we're going to calculate the date. So that means you're solving for x, because x is the date, when there will be when there were exactly 500 new cases of coronavirus in Washington. So write the equation. Okay, and this time the 500 is the y, new cases. So 500. And then get the x by itself. So solving for x. It's okay that you get a negative here, because you're going to divide by a negative in this step. Oops. So when you divide, you get about 4.8. So we'll round it to 5. So about 5 days after March 31st, there were 500 new cases of coronavirus in Washington. Okay, so this is similar to the type of work you're going to do for your project. So these are like sample projects. So I hope you have a great day, and you can start collecting data for your project. And I'll post a short video just giving you the overview of the project. Take care. Bye-bye.